Hey guys, this is Simran and welcome back to my channel. Today we'll be talking about MCPs in the context of unified communications. I've been working on this stuff for a few months, but lately I've been getting a lot of questions about MCP from colleagues and from people with whom I've interacted online. Their questions usually range from what MCP is, how it is related to LLMs, and why can't we just have an LLM talk directly to an enterprise system like Cisco CUCM? And honestly, I think most of the explanations online are either way too abstract or way too polished. So in this video, I will walk you through what MCP is, how it really works in practice, why do we even need MCP at all, and how and where exactly these MCP servers are placed in this journey from LLM to enterprise applications. And then I will wrap it up with a sample use case and a demo of MCP server in action through Claude Desktop. Some of the explanation and demo will be around unified communications, but you do not need to necessarily restrict your own imagination to a certain specific technology domain because the concepts are technology agnostic and they work everywhere across different technology domains. So let's start with something that sounds very obvious, but is quite easy to miss, to be honest. The question is, why can't LLMs just talk directly to an enterprise system? And there are multiple reasons behind it. The LLMs don't actually do things. They don't execute code logic, and they do not understand system boundaries. So they're basically really good text predictors at the code level. For example, you can ask an LLM, "How do I configure call routing in CUCM?" And it will give you an answer. Whether that answer is good or bad is a topic for another discussion. But if you ask it, "Go and configure different call routing components in CUCM for me," now that's a completely different problem because now you need credentials, you need permissions, and since you're working with the actual application through APIs, you also have to worry about API specific restrictions like rate limiting, etc. And none of that belongs inside a model. An LLM AI model is not supposed to be treated as an application. So now the question is, how do we make LLMs talk to enterprise applications? And that's exactly where MCP comes in. So the question is, what is an MCP? So MCP basically stands for Model Context Protocol. It is not a model or a framework, it's just a contract, a protocol, a set of rules that govern the communication between LLMs and the MCP server. MCP basically defines how an LLM asks for an action, how tools are described, how arguments are passed, and how the results from the enterprise application are returned back to the user. So what MCP is doing is basically introducing this middle layer. So instead of LLMs talking directly to an enterprise application, we now have this middle layer of MCP that has two subcomponents, server and tools. And this is now what is governing the communication between LLMs and the enterprise application. And this separation is basically everything. As you saw earlier, one of the key components, or in fact, the key component in my view in the MCP realm is a tool. So a tool, aka a function, is just a regular boarding function that executes certain code logic. For example, if you are using Python, then these are just regular Python functions. They are not AI or anything fancy. A tool, however, does not decide when it should run or analyze users' intent. So basically, it does not do any sort of reasoning. That is the job of the LLM model, and that logic should never be a part of the tool's definition. A tool is something that abides by this statement. It has a certain set of inputs. It is supposed to perform a certain specific operation on those inputs and just return the result. For example, here we have two variables with a value of 5 each, and the tool aka function is expected to return us a sum of these two values. And in this case, it does exactly that. So that's pretty much it. That's it. That's how a tool works. In the case of unified communications, for example, we can have functions that can give us a count of all phones in the enterprise, or we can do some further filtering on those phones by model, or we can basically execute any sort of operation that is applicable, that is permitted through that product's APIs. We'll actually talk more about the use cases in the later part of the video. So if you ran these tools, aka functions, manually, you would get the same result every time. It is no different than running a regular Python code and getting the output directly on console. The actual intelligence lives in deciding when to call them and not how they work. So, another way to think about tools is as a fence. The LLM is only allowed to see which basically tool exists on the MCP server, read their descriptions, and pass arguments that match the tool's schema. LLMs cannot bypass these tools and invent new operations or execute arbitrary commands and or access systems that are outside these tools. So basically, we are not permitting LLMs to take direct control of the enterprise applications. They have to reach via the MCP server. This MCP server is where the boundary is usually set. So from CUCM or any other application's perspective, nothing has actually changed. It is still just talking to an incoming API request, which is now, in this case, coming from the MCP tool. Now, let's look at some code. This is one of the functions which is exposed as a tool through my MCP server called CUCM MCP server. This tool has a certain schema in the sense that it has an argument called device model. It uses that along with this doc string when talking to CUCM to find out how many phones have more than one line assigned to them. The LLM, on the other hand, does not know anything about CUCM. It does not know how CUCM works, and it doesn't even care. All it sees is, if I call this tool with this argument, I will get the output back. Similarly, there is this another tool that is supposed to look for extensions that do not have a voicemail profile assigned to them. And this is again useful from audit point of view. So these two functions are handling two different use cases, and as I'm sure you can see, these tools have nothing special going on. They have nothing out of the ordinary contained within themselves. This is a simple Python function which is calling another Python function, and this other Python function is actually doing all the heavy lifting of API communication with CUCM. So let's have a look at what this function is doing. This is the function where the actual API communication is happening with CUCM over SOAP standard. If you haven't worked with CUCM APIs or APIs in general, then you can go through my blog. I've written quite a few posts on APIs, especially in the context of unified communications. Now, as far as all this code is concerned, you can of course keep it separate like I have, or you can move all of this into the main function here, and that will work in a similar manner. It's just my practice of keeping things separate, but yes, it is entirely up to you how you want to structure your code. Before we go to the final demo, let's have a quick look at how this whole communication happens once again. I think this flowchart will help you gain more visual clarity of this process. So we start off with a user like us throwing a message to the MCP client. The MCP client, with the help of the LLM model, passes the message and determines the intent and the context behind that question. Then it checks its internal repository to see if there is any MCP tool that can be used here. If there is no tool, then it answers the query in a regular manner. And this behavior until now is exactly what you see when you interact with Claude LLM via Claude Desktop in a regular manner. But if the client realizes that it has a tool that can answer the question, then it goes on to select that MCP tool. Once the tool is selected, it constructs a JSON payload and sends a post request to the MCP server. The MCP server receives that request and starts executing the code written inside that specific tool. And this is exactly where we see the communication with the enterprise application happening. Now, as a part of this code execution, it sends an API request, just like I mentioned earlier, to the enterprise application. In this case, it's going to be CUCM. The request then returns a response which is processed by the MCP server and then once again fed into the LLM, which is one of Anthropic's LLMs in this case, running inside the Claude Desktop. The LLM then prepares that response in a simple, easy to understand, human friendly manner or language and returns it back to the user. As I had mentioned earlier, we'll be using Claude Desktop for demo because we want to see the actual workflow that we just reviewed in real time. And this application makes that entire process visible. And there is nothing special about it in the sense that it is just acting as a standard MCP client application that is just following the protocol. So when you ask something here in the chat that needs real data, we'll actually be able to see it deciding to use a tool and then choosing a tool and then filling in the arguments. That's just standard MCP behavior that we will be able to observe in real time here. Now, some of you may have a legitimate question in the sense that how does an MCP client like this know about our own private MCP server? Now, that is usually done by modifying the Claude's configuration file. So for that, we go to File and then Settings and then Developer. And this is where we attach our MCP server to the application. Now, in order to do that, you have an option to edit the configuration file. So let's click on Edit Config and let's have a quick look at the actual configuration file. Okay, so as you can see, this is a pretty standard JSON configuration file. Within the MCP servers section, we have this MCP server. This is the one that we reviewed in when we were looking at the code. This is our MCP server. Within that, we are giving a path to the Python exe file, and the actual MCP server file is given as an argument. If this config file is good and is properly formatted and there are no errors, then you should see your MCP server in the running state. Now, in our case, it is in running state, so it means all the tools that we have exposed in our MCP server should be available to us when we start chatting within the tool. So let's check out the demo now. Let's click on new chat here. Okay. Now, in fact, I just mentioned that if our question or our query needs to, pass on some real data, we should be able to see all the actions that the MCP, server takes behind the scenes in real time here. But before we actually go down that path, let's actually start by asking Claude if it can even read or if it even knows about our MCP tools. Although the server is in a running state, so it should be, but it's worth checking it once again through the chat. MCP tools, do you have access to? Okay, let's see if it comes back with a response. Okay, yep. As you can see, it is able to recognize our tool and it has access to the MCP server, and through that it is able to go through both the tools, and then it is adding some additional context here if you want to proceed with it. So we know that, okay, the things could look on paper. Now let's ask a simple question that we expect users to ask if we had such a system in production. So let's see how many lines are missing the voicemail profile. Let's see if it is able to pull up that information. Okay, now you see it is picking up this tool. It's already recognized that out of the two tools, this is the tool that is supposed to be useful in this case. And this tool, if you remember, had no arguments. So that's where nothing is being passed on in the request JSON. So the results came back and it says there are three extensions that are missing voicemail profile: 1100, 6014, 8874. Now, of course, we cannot rely purely on this. We have to validate it again in the actual system. So let's look at the first extension, 1100. Let's see and validate this output in the actual system. So I'm logging into the call manager now. So we have the first extension as 1100. Let's see, 1100. Okay, yeah, it is missing the voicemail profile, so that is good. Let's check the second one because we got three extensions. So 6014. Okay, this one is also missing the voicemail profile. Let's check the third one. Okay. Okay, yeah, this one is also missing the voicemail profile. So looks like this result that we got was fine. There was nothing wrong with it. Let's try a different question because we had two different tools. This one was talking about the voicemail configuration. The other one is about the phones. So let's see how many 8861 phones have more than one line. Let's see if it is able to pull up that information. Okay, now you see it's picking up the right tool again, and this time it is passing in the argument. So this is the schema. This is a part of the schema definition that we spoke about when we were looking at the video. If you go back to the video, this is what we were talking about when we were talking about the schema definition. So it knows that there is the Cisco phone model in the question. It pulled up that information, passed it on as a value to this argument, and looks like there is just one phone, one 8861 phone, which has more than one line. So let's see if this is true. Okay, yeah, you see this has two extensions here, so this one is good. But we also want to check that it is not doing some weird, understanding of the code in the background. So let's actually look at all the 8861 phones and see if there is any other 8861 phone which has more than one line but is not picked up by this MCP tool. So I think this is the one that we just checked. Let's see. So this is 1, 2, 3, 4, 5, 1, 2, 3. Okay, so this the first one is what we got from the LLM. Let's try the second one. Okay, yeah, this one has one line. This one does not have more than one line. So this was not picked up by the code. So that is good. So out of the two 8861 phones, one has two lines, the other one has one line. So it gave us the right answer. Let's see. Let's try it for maybe 8841 model phone. 8841 phones have more than one line. Let's see if it is able to pick that up. Okay, it is picking up the same tool again, and this time it is passing Cisco 8841 as a value to this argument, device model. Okay, it is thinking a bit here. Okay, so it looks like there is one Cisco 8841 phone that has more than one line. So let's check this phone. Okay, so that's device name. Okay, yeah, this is good. So we have two extensions here. So this one was picked up. But let's try the same second set of validation here that we did for 8861. Let's see how many 8841s do we have. Okay, so we have two, and the one that we got in the result was 22345. So the second one was given to us as in the result. So let's see if the first one has one line or two lines. Okay, so this has one line. So the scenario is similar to what we encountered with 8861. There are two 8841 phones. One has one line, the other one has two lines, and we got the correct result here. In fact, let's actually try a different query here. How many phones in total have more than one line? So now we are not specifying any specific model, okay? And so it should technically look at all the phones, because that's one of the conditions that we have defined in our code, that if the user's query does not explicitly provide the model number, then in that case it should look across all the models available within call manager. So let's see if it is able to do that successfully here. So now we have not provided any model. Okay, looks like it is going back to the previous responses that it has generated, but we don't want that, because based on the information I've gathered so far, I can tell you that at least two phones. This is only from the two specific models that we have checked. If you would like me to check all the other phone models, yes, we want to do that. Yes, let's see if it is able to modify the query and do a brand new search. Okay, so let's look at what's being passed on in the tool. Now you see there is no specific device model. It is passing all as the keyword here in the argument, and we have a condition that satisfies this sort of query in the actual code that is communicating with the call manager APIs. So let's see if it is able to pull up that information successfully here. Okay. Yeah, it's taking a bit of time, but let's wait for it to complete. Okay. Now it looks like we have a third phone. So it is able to find three phones. We already know that there are definitely two phones, because we checked that information earlier. So 8861 had a MAC of this 1, 2, 3, 4, 5, 6. So this is 8861. Okay. 8841 was 2, 2, 3, 4, 5. Okay, 2, 2, 3, 4, 5. So this is a new one. This is a new phone. Let's see what model this is, and if it even has more than one line. Okay. Okay, so that is an 8865 model. Okay, yes, it is indeed true. It has two lines, so that's the reason why it came up in our result. So looks like we have tried different combinations, and every single time it has worked. Now, of course, the reason it has worked is because we have accounted for all the conditions in our actual code. Because your tool aka function is as intelligent as the code which is written inside that function. So you can expose as many tools you want. If they are not actually able to handle the data which is being sent by the product API, they would not be able to pass the appropriate information back to LLM, and then in turn LLM won't be able to do anything substantial. Now, once again, I want to reiterate is that this outcome that we are seeing here vis-a-vis call manager is not generated by Claude LLM. I know I'm repeating myself again, but I want all of you to be very clear on this, because I've seen people getting confused between the LLM output versus the MCP tools output. This actual output, like these MAC addresses or the extension details, these are coming as a result of the code that we are executing on CUCM, via MCP Tools. That tool is being fed a natural language prompt like the ones that we issued in this application, from which LLM is passing the context and the argument, which is then fed into the tool, which in turn uses that to communicate with the call manager APIs, and the final raw data from the call manager is fed back into Claude LLM to convert it into a user friendly format. And that's how that whole workflow that we reviewed earlier works, and that brings everything back to the original position. Now, these two tools are literally just a tip of the iceberg. How far you want to go is actually, to be honest, up to your own imagination. You can make tens of such AI tools across different applications based on your use cases. I have personally worked with a few of my customers to create not just tools, but custom MCP clients and servers, and integrate them with their collaboration platforms like WebEx and Microsoft Teams that work with their unified communications infrastructure. If you are interested in learning more or want to chat on that, then please feel free to reach out via my YouTube channel or my blog, or just hit me up on LinkedIn. In the next video, I will show you how you can build your own custom MCP stack, including the client, tools, and the server, and utilize it as a bot in WebEx or any other collaboration platform. Because that's how things are usually done on a large scale in an organization. We do not install Claude Desktop on every laptop to make this MCP integration work. So stay tuned for that next video and its corresponding blog. If you like this video and found it useful, then please subscribe to my channel. That helps a lot. I'll be posting a lot of interesting stuff in the coming days. And thank you once again for visiting. Take care. Bye.